Watch as the traditional search bar expands into a conversational interface. This transition marks the integration of generative AI, changing how users interact with information. Standard SEO techniques are often insufficient to capture attention when an AI engine is synthesizing its own response rather than providing a list of links. Modern visibility requires satisfying three distinct algorithm types at the same time: classic SEO, answer engine optimization, and generative engine optimization. Traditional, isolated content, like a standalone blog post, lacks the internal architecture these new engines look for when deciding which sources to trust. When an AI crawler scans an isolated page, it finds no structural links to broader authority. Without those signals, the crawler rejects it as a primary source. Relying on these disconnected pages leaves a business acting as a passive digital brochure, failing to provide the verifiable data AI models require. Securing AI citations requires a move toward an interconnected knowledge node strategy, a system built on specialized topic clusters and hidden schema routing. This blueprint grid represents the technical environment where we will build the visibility model. Classic SEO demands keyword optimization, backlink architecture, and a verifiable geographic footprint to rank in traditional search. Answer engine optimization, or AEO, focuses on feeding data to AI assistants like ChatGPT, Gemini, and Copilot. These assistants retrieve data based on natural language queries, meaning they prioritize content formatted as direct questions and answers. Then there is generative engine optimization, or GEO, which targets the engines synthesizing complex research for users. GEO algorithms require deep contextual data, such as white papers and industry trend reports, to benchmark and recommend a brand. The conflict is structural. One web page cannot effectively serve as a short Q&A, a massive analytical report, and a geo-targeted service page simultaneously. When these three different algorithms pull at a single document, the content fractures. It becomes too diluted to satisfy the requirements of any single engine. Because each engine parses data differently, businesses must move away from catch-all pages and towards specialized, single-purpose content nodes. The foundation of this strategy is the central conversion hub, the main website, and the Google Business Profile. We place that conversion hub at the center of our digital architecture. We then deploy specialized microsites, organized into clusters that orbit this central core. The first specialized node is the description microsite, built for AEO. This node uses FAQ formatting to provide AI engines with direct citations they can use for immediate answers. The second node is the features microsite, built for GEO. This node contains authoritative process explainers and reports, providing the contextual depth that synthesis algorithms require. The third node is the SEO microsite. Here, we use service deep dives and location-specific keywords to capture traditional organic traffic and build backlink authority. This segmented architecture ensures that, regardless of which crawler analyzes the data, it finds a format specifically optimized for its retrieval method. Publishing these nodes is only the first step. They must be interconnected to signal topical authority. By cross-linking these microsites back to the central hub, we create a network that proves expertise through data density. This signals EEAT, experience, expertise, authoritativeness, and trustworthiness, to both Google and generative AI models. This interconnected structure shows the algorithm that the business is a verified industry resource, not just a list of services. A cluster of specialized deep dives demonstrates authority in a way that an isolated blog post cannot match. This network effectively transforms a business's expertise into an active community resource that users can follow. By building these clusters, the business gains the trust of the search models, moving beyond the limitations of standard online listings. Securing a citation in an AI response is only valuable if it drives high-intent traffic back to your website or your Google Business Profile. To control this flow, we use hidden schema markup, JSON LD scripts embedded directly into the HTML of each node. If we look past the visual interface of the microsite, we find the raw code layer where the AI crawlers operate. AI models from Google and OpenAI parse structured data faster and more accurately than standard paragraph text. We use specific tags, like FAQ page and local business schema, to define the information clearly for the crawler. These tags explicitly declare your main website and Google Business Profile as the definitive source of the information. This markup acts as a briefing for generative engines. Because these models prioritize unambiguous data to ensure their answers are credible, they rely on these scripts. When an AI model synthesizes a knowledge node, it parses this briefing. This increases the likelihood that the model will use the provided URLs as its authoritative citation. Schema markup is the engineering layer that translates generative visibility into tangible, trackable traffic. Now we can see the complete ecosystem in operation. A user query hits the cluster, the algorithm parses the schema, and the result is a routed citation that leads directly back to the central hub. This strategy allows a business to expand its presence across SEO, AEO, and generative engines simultaneously. Implementing this architecture creates a framework that communicates effectively with both human searchers and AI crawlers. In the AI era, search dominance depends on more than writing better prose. It requires a network of structured data nodes that algorithms are incentivized to trust.